Okay, question number 18. A block of mass 2 kg is released from rest on a slope. Initial velocity is equal to 0. They travel 7 meters down the slope, 7 meters down the slope and falls a vertical distance of 3 meters. Okay, the block experiences a frictional force parallel to the slope of 5 Newton. Parallel to the slope of 5 Newton. Okay, so there is a frictional force acting here. Frictional force acting over here. Okay, what is the speed of the block after falling this distance? Now, what is acting? What is happening over here? See, there are two forces acting. Gravity is acting like this, friction is acting like this. So, as a result of it, it's coming down here. Now, what is the work done by the gravity? Work done by the gravity in moving this object from here to here. See, gravitational force is acting like this over here, right? It's acting like this over here. And then the displacement starting from this point, starting from this point to here is nothing but 3 meters. So, it should now be equal to a force, which is m into g multiplied by 3. Multiplied by 3 meters. Okay, I need not take this one here. If I want to take this one, I can do it, but I should find out what is the component of this force along this direction. Okay, so only then I can do it. But easier way is you can find out directly here. Okay, so if you still ask me why do you want to do this one here, I can always say this is nothing but your potential energy of the object. Okay, the potential energy of the object is lost in moving the object from here to this point over here, right? Loses its potential energy and gains a kinetic energy, right? Okay, so therefore this should now be equal to 2 into 10 multiplied by 3, which should be equal to 60 joules. Okay, so this should be the energy here, but unfortunately as it comes down, it also has a frictional force, right? So what is the work lost by the friction? Because as it keeps on coming down, when it reaches this point here, what will happen? The base of this would have really become hotter here, right? Or maybe it would have been filled up with some sort of sawdust or anything, whatever it's been made out of. Okay, so therefore now what we do is let us find out what is the work done by the friction. What does friction do? Friction tries to avoid it. Now you see, this is 5 Newton is acting like this, multiplied by what is the distance over here? Distance is 7, which should be 35 joules over here. Now is this positive or negative? This should be negative over here. Why negative? Because it is opposing the motion, right? The body has lost some energy. Okay, so whatever energy, if suppose friction was not there, when it came here, it should have acquired a energy of 60 joules. But because of friction, friction takes away a part of its energy. Now what is the total energy the body has? The total energy, W total, is nothing but 60 minus 35, which is equal to 25 joules, right? 25 joules is the energy which it has. Now, how is this energy stored in it? It is already coming out with a good speed over here, right? It is now in a good speed. So therefore, I can say half mv square is equal to 25 over here. Now, what is m here? 2. So I'll substitute the values. Half into 2 into v square is equal to 25. 2 cancels. So v should be equal to 5 meter per second. So answer is 5 meter per second. Closest is 4.9 because we have taken g equal to 10. So this will be a right answer.